Welcome to Theory of Machine. We'll be discussing about the gyroscopic effect on the aeroplane, ship, and stability of two-wheeler and four-wheeler mechanism. So here the terminology what we are going to use is the gyroscopic couple on the disc we are going to count and we are going to discuss in detail. So in the gyroscope we are going to see the vectorial representation of the gyroscope and gyroscopic couple and its effect on the ship and disc aircraft stability. We are going to discuss all those terms. So here we are going to see the vectorial representation of angular motion of the gyroscopic couple, effect of gyroscopic couple on ship, effect of gyroscopic couple on plane disc, effect of gyroscopic couple on aeroplane, stability of two-wheeler and four-wheeler mechanisms. So when you take a gyroscope, here you can take this is the gyroscope. So gyroscope it is meant for measuring or maintaining orientation based on the principles of angular momentum. Gyroscope is the spinning wheel or disc in which axle is free to assume any orientation. So here external torque is minimized by mounting gimbal orientations, remains nearly fixed regardless of any motion of the or any motion of the platform on which it is mounted. So there will be a gyroscopic frame, gyroscopic spin axis will be there, there will be a gimbal, and there will be a rotor. So here when we go with the disk motion, here we are going to consider the various motions of the aeroplane. So here when we take limit with respect to certain values omega into d theta by dt, that will be equal to omega. So velocity is considered, so different elements are considered. So when we go with the if we take the disk when it is rotating at the speed of omega, so based on the direction of view, new axis of spin is generated, that is omega plus of delta of omega. So direction of view where we are going to get, so the new axis spin is generated in the other axis. So in the which it is shown in the figure A. If you take the figure B, you can see delta theta it comes where omega it is going to rotate in one direction, and in other direction new axis of spin omega plus of delta t you are going to get. So in the next axis where we get when you close the triangle, omega plus of delta t minus of omega you are going to consider. So like this, the angular velocity with respect to the magnitude it is considered. So when you consider the gyroscopic couple acting on the disk, so there will be an axis of active gyroscopic couple, there will be a reactive gyroscopic couple for the opposite direction. So here for the axis what we consider, there will be a corresponding shift in the axis where it will be able to measure. So here in the diagram it is shown for every active gyroscopic couple which is in the forward direction, there will be a reactive gyroscopic couple also with an inclination of delta theta. So here G is equal to I into omega p, that is the equation to calculate the gyroscopic couple. So here if you take one axis of spin, so axis of spin for reactive gyroscopic couple, axis of active gyroscopic couple. So here the corresponding planes are considered for the gyroscopic couple. So here plane of precision, axis of precision, active axis of reactive gyroscopic couple, all these parameters are considered. So in each orientation or the direction of axis what we take, the corresponding rotation is considered. So change in angular momentum, that is considered I into omega into delta t. So at last the rate of change of angular momentum it is calculated I into omega p. where omega p is the angular velocity of precision, which it is calculated. So here he defines a problem: a uniform disk of 150 diameter as a mass of 5 kg is mounted centrally in bearings uh, which maintains its orifice in the horizontal plane. The disk spins about its axle with a constant speed of 1000 rpm, while the axis precesses uniformly at a velocity of at a velocity of 100 r at a velocity of 100 rpm. So the distance between the bearing is 100 mm. The resultant reaction is such that the fairing due to the mass of gyroscopic effect. So here he shows the different axes of gyroscopic couple. So for gyroscopic couple acting on the disk, C is equal to I into omega p. So the resultant so reaction with respect to each bearing it is considered RA1 and RB1. So both are resultant. It is going to consider both are in the upward direction.